Hello, today I'm going to do example 2 from section 9-1. A medical research team conducted a study to test the effect of a cholesterol-reducing medication. At the end of the study, the researchers found that of the 4,700 randomly selected subjects who took the medication, 301 died of heart disease, and of the 4,300 randomly selected subjects who took the placebo, 357 died of the heart disease. At alpha equals 0.01, can you support the claim that the death rate due to heart disease is lower for those who took the medication than for those who took the placebo? Well, since we're comparing the death rates of two different groups, this is going to be a 2 proportion z-test. So we need to make sure we meet the requirements for a 2 prop z-test. First of all, we need both samples to be randomly selected. Check. They need to be independent. Well, if you took the medication, that means you didn't take the placebo, so those groups are independent. You need at least 5 successes and 5 failures for both groups. Well, 301 is bigger than 5, and if I take 4,700 minus 301, that's bigger than 5. 357 is bigger than 5, and if I take 4,300 minus 357, it's bigger than 5. So we meet all the requirements. Next, let's find the hypotheses. Well, the claim is that the death rate is lower. So our claim is going to be our alternative hypothesis, and it's that the ones that took the medication, which I'll use row M for medication, is less than row L for placebo. I didn't use P because I didn't want to do P sub P, but P sub L will be the placebo. And then the null hypothesis is that row M equals row L. Since this is a 2 prop z test, this type of distribution is normal. So I'm going to draw a normal distribution. And because the alternative hypothesis is less than, it's a left-tailed test with the area to the left equal to 0.01, our alpha value. Next, we need to calculate our test statistic, and we do that with the calculator. So again, I'm using a Casio calculator. So I go to test, z, 2p. First, I need to type in the alternative hypothesis, which is less than. x1, which will represent xm for us, is 301. nm is 4,700. xl or x2 is 357. And nl or n2 is 4,300. So if I type those in, and that's all we need. Press enter and it calculates our test statistic for us. So our test statistic is equal to negative 3.46. And I do see the p-value there. One thing I do want to point out about the p-value is don't forget when you're reading the p-value to look at the end. This is e negative 4, so that means there's 3 zeros in front of this too. If you choose the p-value method. But I'm going to do the critical value method. So for the critical value method, we need to find this cutoff value. To find that cutoff value, we need to use an inverse function. And since this is a normal distribution, we will use inverse norm. So inverse norm, we need the area to the left, need the standard deviation, and the mean. Remember, when you're finding critical values, you're using the standard critical value. So this will always be 1, 0. It won't match the sigma or the mu from the problem. So if we go there, It's under distribution, normal, inverse normal, left area 0.01, and we're good. So we're getting negative 2.33. So that's this cutoff value. Then Z star falls over here because it's in negative 3.46. So since Z star is in the rejection region, we reject the null. Since we're rejecting the null and our claim was the alternative, that means we support our claim. So there is enough evidence to support the claim that the death rate due to heart disease is lower for those who took the medication than for those who took the placebo. And that is it for example 2.